I always try and make it a point to at least do a cursory inspection of any tool before I use it, whether that be a handsaw or a powered tool or something like our sawhorses we have here. So many of the hardware connections on this that allow us adjustability of the legs very easily with wing nuts can also easily result in that hardware coming loose and getting lost, which would be a huge pain in the ass if you were on a job site and you suddenly realized that you had hardware dropping off and you were missing parts and pieces for it. So there's one good reason. And then from a safety perspective, you know, you don't want to have something dropping away or falling apart while you're working on it. So I go through and I just do a kind of quick check and see, like, you know, if there's anything that requires adjustment. And so when I'm making adjustments to nuts in particular, I always recommend using a box wrench instead of an adjustable wrench if you can afford to have a set or do have a set of box wrenches available. So open-end box wrenches allow me to have more accurate purchase with that hardware and is less likely to gall up or deform the facets on that nut than is an adjustable wrench, because this is engineered specifically for that. So I did notice that the legs were a little bit sloppy, so I went ahead and I snugged these guys up and just gave them a little turn just to put some more tension on it, and then check to make sure that the range of motion on them was still good, right? And but I also noticed that the rivet that was holding this handle on blew off, and I'd forgotten all about it. So we're going to jump on this and turn this into a little demo about how to install rivets, and how to remove broken rivets, and then how to install a new one. So we're going to pull up a little bit closer for that when we start to actually get into the action, but this is what we're going to need to make this happen. We're going to need a drill that's going to allow us to be able to drill out the original pop rivet or blind rivet. And I want that drill bit to be a little bit smaller than the pop rivet so that it is boring out the center and just leaving a little sleeve in the inside there that I can push out. That way I'm not taking a chance of opening up the original hole larger than it needs to be. Now, maybe you're having a good day and you're able to just come in and actually push a rivet like this out through that hole, but it's very rare that we have that kind of luck working for us. But again, drilling it out is an option. So my first drill size is slightly smaller than this 3/16 inch diameter rivet that I'm using to replace it. So I've got an 11/32 inch bit I'm going to do my drill out with. Then I'm going to come back in and clean it up with 3/16, which is the finished size for my 3/16 inch rivet. I'm also going to need to straighten this tab up a little bit that got bent in the process of breaking off, and so we'll do that with a closer look on what's going on, and we'll look at the rivet gun and talk a little bit about that as well before we install. Okay, let's talk a little bit more about pop rivets, how they're defined, and how they work. So rivets, just like us, have a limited grip range, like how much we can grip in our hand at any given time represents the grip range of things that we can gather together. And so when it comes to rivets, the grip range is probably even more important than the diameter of the rivet itself. So here you can see an aluminum pop rivet. It has a mandrel or a stem. It has the head of the rivet, then it has the body of the rivet. When this is installed into the rivet gun, that mandrel is pulled in this direction, which draws this ball end up into the tubular sleeve of that rivet, which forms a head on the opposite side of the preformed or existing head on that rivet. So we have grip range, which has to be sensitive to the combined thickness of the materials that we're joining together. Because if the grip range isn't enough or big enough to gather the materials that we're combining together, then it won't have enough room to form a ball head on the backside. And if the grip range is too large, then it's going to make an excessive amount of balling on the backside or result in a really sloppy, loose fit. So most of your rivet guns are going to, like this Arrow model RH200, which is a pretty good quality rivet gun. Many of the rivet guns that you buy will come with the option of being able to use 4 different sizes of rivets with them. So here we have a 3/16, and this is an 1/8" rivet. So what I want to do is I want to take my stem or mandrel and find the hole that fits properly into, right? And then I'm going to swap that nose piece out of storage to the working end of it. And the way I'm going to do that is by taking the wrench that comes along with this, and with the tool in a closed position. This is very important that it not be in an open position when you do this. With the tool in a closed position, which takes the spring tension off of the nose piece, I can come in, left is loose, take that out, take the size that I need, which is stored on the body of the gun, and install that, screwing it into place by hand, and then securing with a hand-tight turn of the wrench. Then my extra piece goes right back into the body where it's stored so that it's not lost. Now, with the handle in an open position, I can now take the rivet, drop the stem or mandrel down in like so, and watch what happens as I squeeze. Watch how this ball is formed on the end. So I would gather or capture a material between the preformed head and the ball in, and as I squeeze, you can see it draws that ball down, and I've squeezed as tight as it goes. Now I'm going to open it back up. The stem raises up and drops back down, and then I squeeze again, and it will pop the stem off, and the mandrel or stem will drop away. So the frequency of occurrence of those rivets is where we're really gaining strength, typically, like on the wing of an airplane. The advantages of using rivets is they're very low profile and they hold securely. And a good general rule of thumb is when you're working on the larger end, like with that 3/16, it does require an inordinate amount of pressure to get that second or third pole to snap off clean. So we'll talk a little bit more about some of the other rivets that are available for using in a wide range of applications, including applications other than metal, like for wood and leather and rubber and fabric, when we pull back a little bit from this frame. Okay, so we can see where the head sheared off here, and on the blind or the bottom side, there's a little head that had formed when that rivet was set into place. So let's go ahead and drill this guy out. All right, so it's not staying on center very well, so I'm going to move down to a slightly smaller bit. The idea behind going to a smaller bit is that if I'm slightly off center using a smaller bit, it's less likely to compromise the original hole by drilling oblong or off center. So you'll sometimes see me tilting the drill when I'm getting started, and sometimes I'll do that so that if I'm not in alignment, I'll start drilling my hole at an angle, and once I establish what I feel like is a better path, then I'll move up into a straight position and go the rest of the way through. One can also come in and file or grind down that head, but I'd rather not mar this surface up. So I'm going to come in with a center punch and see if I can push the rest of that through. That little guy dropped out with a little bit of push from the center punch. Now I'm just going to double check, make sure that 3/16 opening hasn't been closed up with paint or rust or debris. I'm going to test fit my rivet. That's a good fit in the hole. It has more grip range than I want, but this is the only 3/16 that I have on hand right now. I also want to flatten this tab back out. So I'm going to straighten that out the best I can so that it's sitting as flush to the surface as is possible, because you need a tight fit between those two pieces when you're riveting. Right? So up we go, feed through both pieces. So there we go. So that should feed in. It's a little bit tight, but we want a snug fit with a rivet, right? And now what you're going to see happen is I squeeze on that handle, you're going to see that mandrel pull upward, spreading the bottom of that rivet. It's important that I have good positive pressure downward while I do this as well. And that's my first squeeze. And you can see that drew up that ball a little bit. And now I'm going to open, which lets me drop down on that mandrel or stem a little bit deeper, and squeeze again. And we should hear a pop, hence the pop rivet. And now you can see the stem has sheared off. The ball is drawn up. And now that's as tight as the workday is long. So we really only got a little glance at how rivets are used. And we were looking at what are called blind rivets or pop rivets, and maybe we'll do some more stuff down the road, but I want you to know and understand a couple more things about pop rivets. One is that when you're working in smaller diameters of pop rivets, like 1/8" pop rivets, you're really gaining strength from the frequency of the occurrence of those fasteners rather than one fastener trying to do a lot of hard work. The other thing to know about pop rivets is that they come in a wide range of materials. You can get them in aluminum, copper, steel, stainless steel. You can get them painted with commercial finishes on them to color match something you might be working on. And again, the lower end, 1/8" and smaller, don't require a tremendous amount of strength. But those larger sizes like 3/16, even I have a little bit of a challenge, bearing down on that tool enough to get those rivets to work properly. There are a few fancier versions of the rivet gun that I have, but still, again, buy the best quality rivet gun you can afford, because the low end ones are just not going to perform very well or for very long. But know that there are also some higher end ones that are called ratcheting pop rivet guns that you can find through sources like McMaster Carr or on other sources online. And those ratcheting rivet guns require less hand strength because they have a mechanical advantage built into them that raises it up incrementally with a series of little mechanisms on the inside of it. So if you're going to be doing a lot of riveting, consider that. And last but not least, there are specialty rivets out there that can be used with this gun that work really well for fabric and leather and rubber. They're called peel rivets. And instead of forming having a ball end that pulls up into that bottom of the rivet and spreads it out to capture those pieces, it has these little fingers that bloom like a flower and spread out. So they're really good at distributing load over large surface areas of softer material like fabric, rubber, leather. But know also that you can always use a washer on that bottom or open end of the rivet to distribute that load over more surface area as well if you're working with intermediate thickness of materials where there may be some concern about it tearing out or pulling through. But so that might be using it with something like thin plywood, and also there are all kinds of rivets that are made to install in things like thin gauge sheet metal that give you threaded inserts, and that actually make rivets that are intended to be installed in wood as well that have screw threads on the outside and allows you to screw threads on the inside, so you go in, you drive that rivet into the opening of the wood, and when you come out, it leaves machine threads on the inside to be able to act as a transitional hardware from soft material like wood that we usually use wood screws to machine threads, which are discussed in detail in the Fascination demo. So anyway, thanks again for participating and supporting what I'm doing here, and I look forward to our next project.